kick off anyway. I just want to. This is a really tough topic for me to talk about because I get wildly varying levels of knowledge about it, typically within an audience. So, could you put your hand up if you've read any of Don Reinertsen's books? Any of them? Okay, so not many. Okay. Are you familiar with the term cost of delay? Yeah, a few more. Okay. I hesitate to ask this one. Is your understanding of cost of delay based on what you've read from SAFE? One or two? Okay. Right, we have to sort that out then. I'm afraid to say. I don't know if we just kick off and get going. We might as well, I think. Okay, so this is what we're talking about, obviously. Why cost of delay? So 3 things that I tend to talk about in terms of why cost of delay matters. The first is it's really great for improving the way we prioritize, the way we select what we do, and the order in which we consider doing those. That's not the only thing, though. It does tend to be the thing that people talk about the most, but it's not the only thing, and it's perhaps not even the most powerful part of it. The second part is that it's really useful for making better trade-off decisions. And how many of you here work in some form of product development setting? Okay, good. A couple, 1 or 2. So as you know then, the work that we do is full of trade-off decisions. So almost every day, 100 times a day, that's what we're doing. We're making trade-off decisions. We take this path or that path. We could do this or that. Loads and loads of trade-off decisions sort of embedded in what we do. And then the third thing that I find cost of delay is really useful for is to change the conversation that you're having in your organizations, between the teams, within the team, between senior management and the teams themselves, those sorts of things. So, just to get us in the mood for it, we're going to play a little game. Bear with me. What I want you to do is I want you to imagine you're going to be stuck on a desert island for the next 5 years. It's going to be very boring, 5 years. And I want you to think about what is the one thing that you would take with you. You're only allowed to take one item. What is the one thing that you would take with you? A multi-tool. Anyone else? A what? Your wife? Okay. I'm sure she'd appreciate you dragging her off to a desert island for 5 years. Or not. You're going to be in big trouble, but you got 5 years to figure it out. Anyone else? A machete. Yeah, that's probably going to be quite useful. A desterilisation facility. Okay. Yes, that one. That one. Yeah, that would be quite good, wouldn't it? Anyone else? Someone usually says a sailboat or something like that. Sail away from the island. Okay, so that's great. Just have a think about what it is that you're, that one item. Unfortunately, you chose the wrong airline. You should have travelled with Air New Zealand. But unfortunately, you chose the wrong one, and they lost your item. Your wife, your multi-tool, or whatever else it is that you're thinking of taking. So now what I want you to do is I want you to think about how much would you be willing to pay to get that item that you were thinking about for the next 5 years. You're not going to get it unless you pay for it. Wise man. Very wise. Multi-tool. What's a multi-tool worth to you for 5 years? A lot? Like a year's salary? Or I'm not going to ask you how much you earn. I'm sure it's millions, but you can't work. So it's maybe 5 years worth of salary. It's obviously worth more to you than what it would cost on the market today, usually. Yeah. So what we're doing here is we're actually taking an intangible thing and we're making it quantitative. We're saying what this is worth to us. And in economics, we call this willingness to pay. There are other variations of this, like willingness to accept compensation. So if you already have the item and I take it away from you, what would you be willing to accept in compensation for that thing? Willingness to pay for it is another version of that. So this is basic economics. Yep, we're turning something that's intangible into something that's more tangible. People make the mistake of thinking that economics is about money. It's not. It's actually about the decisions that we make in conditions of scarcity. These are decisions that we're making anyway. We're just trying to figure out the thinking that's going on behind that. So it's usually the scarcity that's forcing us to choose. I only let you choose one item. So speaking of scarcity, let's consider product development for a minute. Yeah? So on the supply side, if only it was like this, if only it was just a tap that you could turn on and the magic just flowed out, you know? You had plenty of capacity, you just turn some on and it happens. But I think you've all probably worked in the industry for long enough to know that this is not real. So in the real world, building up any sort of capacity to deliver takes time. You know, you've got a number of learning curves going on. In particular, the team have to learn how to work with one another. They have to learn about the code base that they're working in and the problem space that they're dealing with. They also need to understand the customers and the users that we're trying to service within this. So there's loads of little learning curves going on and sometimes longer learning curves. So even if you shut off, if you then decide you want that capacity back again, it can take months to get back up to any sort of normal throughput. And this is a cumulative flow diagram that I stole from Dimitar, who's I've seen hundreds of these as well. You've probably seen one too. But basically, this is what it looks like when a team first comes together. Then there's a series of months as they kind of figure out how to work with one another and their code base and what they're actually doing, and then they sort of get ahead of steam and they actually get going. And then towards the end of the project, it sort of starts to tail off. Yeah. So the supply side isn't easy thing to turn on and off. It grows and comes and goes, basically. So the supply side's difficult, but what about the demand side? So the demand side can often feel a little bit like this. Lots of stakeholders, and they all want a piece of you, and climbing over each other to get to you. And sometimes it's not just that they all want a piece of you, they actually want the opposite thing. Yeah, and for all of them, whatever it is that they are asking for tends to be, they consider it to be number one. So when people say, oh, we just need to get better at saying no to stuff, what they really mean is, we need to get better at saying no to all that other stuff, but not my stuff. Because these are the things that I want. So does any of this sound familiar to you guys? Yeah? You've had to deal with this. So maybe an alternative title for this talk would be, how to survive in a world where stakeholders want it all. Yes. Oh, sorry. How to survive in a world where stakeholders want it all. Not only do they want it all, but they want it yesterday. Yeah, they've got a sense of urgency about it as well. So I'd just like to flick it back to you again for a second. How do your teams prioritize? Give me an idea. CD3. You're cheating. HiPPO? There's a HiPPO. Anyone else? How do your teams prioritize now? You use SAFe. Oh, wow, okay. Prioritize backlog? Okay. Well, I've seen a few in different organizations, so I'll just quickly go through some of those. Anyone know where this is? Moscow. Anybody had the privilege of working with a backlog that's been prioritized using Moscow? Must have, should have, could have, won't? Yeah, it basically doesn't work very well. We kind of end up with this committed giant backlog. Everything becomes a must, and you kind of, it doesn't really help. It's categorization. It's not really prioritization. Someone mentioned the HiPPO, which I'm going to talk about in 2 hours' time. How do we can train our HiPPO? So the usual scenario of someone far enough up the food chain decides what's going to be built and what the priority order is. If you're lucky, they'll stack rank it for you. But yeah, basically we defer the decision to some well-paid person, basically. Another version, which is also quite common, is we'll basically divide the available capacity up into teams, let's say, and then we'll allocate some of that capacity to, let's say, a bunch of product managers or product owners, and they will decide, but we'll be even, we'll be equitable across the group. They all sort of get a budget to spend and those sorts of things, which sounds really good until you realize that they all want a piece of the same team, which happens pretty much all the time. So works kind of well, at least in theory, and then you kind of discover that it sort of breaks down in practice. Yes, blind to value also in some cases. And then there's what I like to call the Eurovision model. It's a little bit dangerous talking about this in Sweden because actually you're not on this list, which is kind of fortuitous, I think. But Norway's not doing very well, and United Kingdom's actually doing better than 0, which is pretty good for them. But you know how it is. It's kind of like the horse trading situation. You scratch my back, I'll scratch yours. Different countries sort of vote in blocks for one another. It's not really based on how good the song is, though. It's more based on who your friends are and that sort of thing. So it's the usual kind of favours for friends and a little bit of politics going on there. At least Eurovision is funny, in my view. Whereas the same kind of model in our prioritization systems inside companies, not so funny. Yes. In the project world, especially the bigger projects, we get into more of the sort of benefit-cost ratio side of things, and this is where, again, it sounds good in theory. Well, anything that has a benefit-cost ratio of more than 10 gets prioritized, and we'll just stack rank them according to their benefit-cost ratio. The problem is that just like Jessica Ennis here, who's sort of just scraping over this bar perfectly, it looks effortless, and when you sort of watch her do it, but what you don't see is that she actually had 3 attempts at that. And we see the same thing with benefit cost ratios in organizations, is that the first time it comes up for approval, the answer is, go back and get more information. So they go and get some more information. And then more and more and more and more. So you don't see any of the preparation that goes into it necessarily. And it basically turns into a high jump. It's not really a stage gate. It's a multiple attempts to clear a bar, which doesn't make a lot of sense. Or we could maybe focus a bit more on cost of delay. So something that helps us focus on the value and the urgency, something that helps us with trade-off decisions, and something that helps us change the focus of the conversation. So part of the problem here is that value can be a really nebulous term. It's pretty hard for us to nail down exactly what we mean with it, let alone how we might even begin to measure it. And making predictions is a bit like wishing you had a crystal ball about what might happen in the future. And of course, we don't have multiple parallel universes to just change this one thing and see whether it worked or not. We're making loads of changes all side by side, and it's hard to figure out which one actually made the impact that you were hoping for. I mean, it worked, but which one was it? You're not too sure. So I'm not suggesting that this is easy in at any stretch. So I realize that the value side of things is somewhat muddy and difficult to kind of wrap your head around. But no matter what we do, we're still making these decisions. These decisions get made anyway. We're not sitting on our hands, and we do need some mechanism by which we hold back this demand, because demand will always outstrip supply. And in the line of work that we're in, we kind of need to get comfortable with that idea, because that's the way it is. And even if you could do it all, and even if it's all equally valuable, you still need to decide which one you're going to do first. So you at least have some ordering problem, which we tend to forget. So where do we start? And perhaps more importantly, when should we stop? So, as I like to say, value alone is not enough. We need to have some understanding of the urgency of the things that we're working on. As human beings, we're terrible at separating those two things. We tend to treat the urgent as valuable and the valuable as urgent, but they are two separate concepts. And maybe this illustrates it nicely. So this is a fairly typical value stream map. If you do something similar in your organization, I think you probably find maybe not quite the same numbers, but probably the same proportions. You'll probably find. So this is a feature that comes in. It's captured way back here. It spends 18 weeks waiting for a proof of concept, which took 24 hours, and then goes into another queue for another 11 weeks, and it spends 82 hours going through dev test. And then, of course, they're not practicing continuous delivery yet, so another 9 weeks of waiting before it actually goes into production. Sad story, perhaps, but it's actually pretty common. So total of 38 weeks waiting in this system. The question is, what did all that waiting time cost us? And in this case, and this is a real example, the cost of delay for this particular feature, which didn't take a long time to actually do, 82 hours to actually make the changes, cost $210,000 per week. So it turns into a pretty big number when you add it all up. And then, stop me if you've heard this one before, but we need more efficiency in here. We really need to work on the flow in this part of the system, which looks kind of stupid when you see it end to end, like we need to work these people twice as hard. Even if you got double the amount out of them, it's still not going to fix the problem. So this is a classic scenario. We're not actually considering the whole, we're just considering this one piece of it. And then we get this very strange urgency paradox that Don Reinertsen talks about. So before it gets to the team, it's not that urgent. And then all of a sudden, it's really urgent. The truth is the cost of delay hasn't changed. In this particular example, the cost of delay hasn't changed at all. It was costing them $210,000 per week way back here. But it was only when it got to here that people started jumping up and down about it. Like, where is it? And even more amusingly, anyone want to guess as to why they did a proof of concept? Why do a proof of concept for this thing? I mean, it's 82 hours worth of work. Why do a proof of concept? No guesses? In this case, it was because they had a KPI on the accuracy of their estimates. And so, of course, one wouldn't want to give an estimate without it being super accurate. So let's do a proof of concept to make sure our estimate is accurate, which is pretty stupid when you think about it, right? It's kind of sad. Yo. This is one feature flowing through the system, yes. Yeah, they're flat out. They're not sitting there twiddling their thumbs. They're working on 100 other features, Oh, yeah, well, in theory, you could add them all up. I mean, we're talking economic value here. We're not talking financial value. So it's not actually coming out of the bottom line of the company. But this is money that was on the table, which they could be making, which they're not making. Yeah? But you're absolutely right. It's not that these teams are sitting around for 11 weeks doing nothing. They're busy working on other things because they've got a massive WIP problem. They're very busy doing stuff, but it's very slow end to end. So I think I asked earlier about who had read any of Don Reinertsen's books. Don is the guru behind this, if you want to know anything about it. I definitely recommend the blue book. It's hard going, but it's worth it. There's nice little bite-sized chunks in there that you can read. But in his words, if you only quantify one thing, quantify the cost of delay. So what is this cost of delay thing? So very simply, all we're talking about here is trying to say, what is the impact of time on the outcomes that we're hoping to achieve? That's it. And I know that's easy to say, and maybe getting to it is a little bit difficult. So the way I normally go through this with organizations is that I tell them I have a magic wand in my bag here, and I'm going to wave this magic wand, and I'm going to give you this thing that you're asking for. So here it is, boom. And then I ask, what would that be worth to us if we had it right now? Is that $1,000 a week? $1 million a week? Somewhere in between? Like, just give me an order of magnitude. It doesn't need to be super accurate. I just need some idea of which end of the scale or beyond this particular thing is. And if there's a date that's already been set by someone in the organization, oh, here's the deadline for this thing. Well, then I ask, well, what would it be worth if we got it a month earlier? Is that worth nothing to us? Or would it be worth something to us? I don't know. Or What value would we lose if we got it 1 month later? We're having a conversation over breakfast this morning about some of the tyranny of deadlines. And part of the issue we have with deadlines is that they're treated as very binary. So we have a date that we're shooting for. The loss that we're experiencing, the economic loss that we're experiencing before that date, we assume is 0. And the economic loss we assume after that is the entire amount, which is 99 times out of 100 not true. So what we're doing here is we're putting a price tag on time. We're combining value and urgency, and that gives us a cost of delay. So let's drill into the value side just quickly. So a framework for thinking about this that I've used in a bunch of different organizations, which I've found is a useful scaffolding for thinking about value. I haven't managed to break the model yet, but if you can think of something that breaks it, I'm totally up for hearing about that. So there are 2 things which look at the revenue side of the equation and 2 that look at the cost side of the equation. So the first is about increasing revenue. So what is this thing that we're doing? Is it about increasing the number of customers or the sales price or whatever it happens to be? We're basically going for new revenue. The second, protect revenue, is about looking after the existing customers we've got. So if we don't look after them, they may well end up switching to some alternative. So what are we doing to protect that revenue? And then 2 on the cost side. So 1, what are we doing to reduce the costs that is this thing going to reduce the costs that we're already incurring, so therefore we have some numbers about it? Or is it about avoiding some costs that we might incur if we don't do something? Does that make sense? I won't go into any more on this. I've written up tons on it, so you can go and read that if you like. And then we basically go through this process of, here is this project or initiative or feature or whatever it happens to be, and we go through, why, a bunch of times, and eventually, through making a series of assumptions, we normally arrive at 1 or more of these buckets as a general rule. Quite often more than 1. So it's not exclusively, oh, that's only this one and not that one. Critically, we need to make those assumptions visible, because we have to make some assumptions in order to get to the number. And then if they can't put a number, I'm kind of like, well, maybe it's not worth anything. Let's not do it. That doesn't always go down very well. They normally sharpen their pencils at that point. Oh, okay, well, no, it's probably worth, something like this. This is not about precision. It doesn't matter if it's, 1.05 million or 1.15 million. Its order of magnitude is generally, better than nothing. I'd probably start with that sort of thing. And I'll tell you a little bit about why a bit later. So a couple of tactics for getting to it. So the first, we make the value equal to the cost of the alternative. So if you're automating a process, well, what does the current process cost us to actually do? So it's going to be faster, so there's less waiting time for the customer, so we're protecting revenue. We've got current manual costs, which we're obviously going to reduce. We've got cost of human errors, so we're going to avoid those costs in the future, as an example. Or we could estimate the value of the effects of the change. So let's say we're going to improve invoice accuracy and clarity. So that's going to help us to reduce payment delays. It's going to make it easier for customers to pay the correct amount, so therefore they're going to be less pissed off with us. And it's going to use less employee time processing customer inquiries and complaints. I see a lot of business cases or estimates of cost of delay which focus almost entirely on this bucket here, reduce cost, when often this one is an order of magnitude or more than this, which is, until you actually ask the question, you don't get an answer. Sometimes it's difficult for them to estimate, but we're making these decisions anyway. So that's the value side of the equation. Let's quickly look at the urgency side. So, warning, I know it's after lunch on a Friday, so you're probably all a little bit sleepy, but we can do a little bit of calculus. Yay! So pay attention to what's on the y-axis. It annoys me a little bit when I see people being unclear about what's on the y-axis. They just say value or impact, and I don't know what that means. Are you talking cumulative? Are you talking per week? What is it that you're talking about? So important to be clear about what's on the y-axis. So this basically builds up like this. Let's say we're automating something. When we switch it on, our benefits ramp up, and then we basically get those benefits in perpetuity for some long enough time that we don't care about when it starts to ramp down. So it just goes on for a long time. So this is for features where the benefits have a very long life and the peak is unaffected by delay. So then what happens when we're late? So it comes in a bit later, or it's delayed in some way, shape, or form. So basically, when we actually get to switch it on as here, we have the same ramp up as we had before, because if we don't, then why didn't we do that the first time? So usually these are parallel to one another. And we achieve the same peak, because the peak is unaffected by delay. So it doesn't matter when we automate the process, we're going to get the same amount of value per week out of that thing, right? So you can see where I'm going. You take the area of one curve, you subtract the other, and we basically get a delay cost. If you make this late entry equal to a per week figure, then you'll get the cost of delay in per week. Did everybody follow that? Make sense? Okay. This is really easy to work out. You don't have to be that good at calculus. It's a very simple parallelogram. We take the base times the height, and it's, yeah, fifth form maths can do it. It's not that hard. This is just one of the urgency profiles that I have observed. So there are a number that I've observed, different patterns that repeat, and this is based on not thinking about what they might be and then looking for it. It's based on observing what we're seeing, and then the patterns have emerged. I see other urgency profiles that are mostly theoretical. People have sat down and sort of scratched out on a notebook what they think the urgency profiles are. A lot of those don't actually happen in reality. So, whereas these do. So this is a very common one. I would say this is the most common, especially in most big corporates. The peak is not affected by delay, and the benefits are long-lived. So very common. We do a lot of automation with software, right? So tons and tons of this style. If you happen to be in fast-moving consumer goods, fashion, those sorts of things where things come and go, and therefore there is not just a time to market issue, but if you're not there, if you don't get in time, then someone else gets there first, and then there's some ramp down of the benefits that are available. This is not that common, but they do exist in some cases. So in this case, it's a relatively short benefits horizon, so it's not 20 years or 10 years, it's more like 6 months. And then the peak is affected by delay. Does this make sense? Yeah? Again, the difference between those two is not massive, so you can actually approximate it pretty well just with a parallelogram. It's the same math if you want to roughly do it anyway. Where it gets a little bit more complicated is when you have multi-sided markets or any sort of network effect. So if you're Uber or Spotify, for instance, and you're therefore worried about, once basically the more listeners you have, the more artists you have on it, those sorts of things, or the more drivers you have, the more riders you're going to have, that sort of any sort of multi-sided market where there's some sort of lock-in, then not only if you're late, so the benefits have a very long life, but if you're late, you get a reduced peak, and that peak is generally impacted for a very long time. So these ones are super expensive in terms of cost of delay. Making sense? Okay. And then there's a fourth, which is not actually as common as you'd think, because there's some sort of date or some sort of seasonality. The patterns that you tend to see in organizations, the way that they deal with urgency is to add dates to things. That seems to be our primary mechanism. But in reality, those dates are just made up. They've been plucked out of someone's nose or other places. So in this case, this would be like a regulatory thing. So the regulation kicks in here. The regulation kicks in here, so we need to have delivered it by here. So we have the ramp up, and then we're saving the manual workarounds that we would have had to do in order to meet this regulatory requirement. And then it goes on for as long as the regulation exists, right? Of course, makes sense. But there is some sort of option expiry date, or a date at which it needs to be done by. Be very careful with the dates. Those dates should be external dates, not internal dates, like marketing department wants it by this date. Those tend to be bullshit as a general rule. There are different forms of the things where we have dates or seasonality. So this would be one, if it's related to Christmas season, for instance, or holiday, whatever you call it. We call it Christmas in Sweden. Where basically if you don't have the product ready or the feature ready for that particular period, that seasonality, then you basically have this reduced peak because someone else gets there first, or the value that you get out of it is less. But again, there is some sort of date associated with it, but it's relatively short-lived. So those are the different urgency profiles that I've seen, 4 of them. Only the 4th one has a date. And then there are any of those other 3 shapes can be attached to the date version. One thing which I need to mention, which is, again, I mentioned it a little bit earlier, that we're talking about economic value here, not financial value. So the information that we're generating as part of what we're doing is actually valuable to us. That changes the things that we would do, and so therefore it has some value to us. So as I like to say, product development is a journey of discovery. So do we take the path on the left or the path on the right? Well, if I knew in advance that the path on the left led to a cliff and then I'd have to walk all the way back, then I'd like to know that sooner rather than later. That's worth something to me. And we have that same thing within software development all the time. So different ways we can quantify the value of information. We can basically go, what's it worth to us to avoid taking the wrong path? What's it worth to us to not build the wrong architecture that doesn't scale, as an example? What would it cost for us to obtain that information firsthand, to actually build that architecture, discover it doesn't scale, and then come back and build the one that does? What would that cost us to actually get if we were to do that ourselves? Or you do as the pharmaceutical companies do, or the oil companies do, they're willing to pay for that information. So they'll take an early stage drug research that has gone through a series of information gathering exercises, because that reduces their risk. That's worth something to them. They're buying information. So what would we be willing to pay for that information? Let's look at a few concrete examples. Again, these are real. So requirement number 9076. Improving invoice accuracy leads to a reduction in the number of customers who pay late. In this case, this organization had revenues in the billions, so actually shortening the payment time for customers was worth quite a lot of money to them, 4 million per annum. A lot more than the cost of dealing with the calls that came into the call center. So again, make sure you consider all of them around it. So it's pretty simple maths. 4,100,000 over 52 weeks. It's about 80,000 per week. The math is not difficult. Everybody follow that? Makes sense? I get this question, why express it in weeks or months? I prefer weeks because it makes a lot of the trade-off decisions that we make a lot easier to make. I know that if it's $80,000 per week and I have different decisions I can make, then it's much easier for me to make that call, to save a week, for instance. Another version of this, mostly avoiding costs, 8,000 per week. Yeah, it's not. In this case, it has a last responsible moment of the 1st of June. So this is the key thing, is that when you add a date to it, and this is a little bit of a hard one to get your head around for people who are used to putting dates on things, putting a date on it tends to make the cost of delay 0 until you get to that last responsible moment. And they're pretty confused when they say, well, it has to be done by this day. Oh, okay, great. That means the cost of delay for us working on it today is 0. And then when we get to the last responsible moment, it will jump up to that figure that we've now worked out, $8,000 per week. And then they realize actually putting a date on it doesn't help. Another one. In this case, this is about avoiding costs. They had to make some brave assumptions about this because they'd never been fined before for this particular thing. A new regulation came in. We don't know what the fine is going to be. We think it's going to be worth $500,000 per vessel calling into this port, which happens to be Algeciras in Spain. They also didn't know what the probability of getting fined was. In fact, it's a new regulation. Maybe we will get away with it for a while, so it's not that big a deal. But in this case, they worked it out. $1 million per week was the cost of delay for this. So pretty large sum of money. So this makes scheduling decisions really easy, right? Which one of these would you do first? Pretty simple. Okay, but it's not that simple because they don't all take the same amount of time, right? So I know it's kind of unpopular sometimes to say these things, but it is kind of helpful at the portfolio level to have some idea of how long things are going to block the pipeline for. So when the time required to deliver varies, we use cost of delay divided by duration, CD3. So we're taking value and urgency, goes into our cost of delay, we divide it by sum. You can do t-shirt sizes, elephants versus cats. I don't care what you do, you just need to be consistent with it. How long is the pipeline going to be blocked for? I'm running out of time, so I'm going to race through these. You've probably seen these anyway, but basically comparing different scheduling methods, first in, first out versus CD3, you get a massive reduction in the delay cost, so it makes a lot of sense. If you're struggling to sleep, you can work out the math for yourself. It's not that complicated. Oh, key point, people make decisions, not the algorithm. The algorithm's pretty stupid, really. So don't trust it with your life. Don't be so open-minded that your brain falls out. There will possibly be some additional additional levers that you put in there. So it may have a really high cost of delay for us to open a pizza shop over the road, but that's not the business we're in. That's not why we come to work. So even though it has really high cost of delay, we're not going to do that. That's fine. Technology strategy also. So in the real world, I suggest starting with CD3 as an initial triage of all of the things coming in. Adjust your cost of delay to reflect this strategy, and make sure you state reasons for adjustment. Don't adjust the CD3 score, adjust the cost of delay itself, because then you know how much you played with it, basically. I get this question a lot, why duration and not cost? Which of these three is the most scarce? It certainly isn't money, because we can beg, borrow, and steal that. It's not capacity. We can do some stuff around scaling. Not easy, but we do have some flexibility. Whereas time, it can't be replaced, can't be reversed. The 40 minutes you're spending with me, you're never going to get back, I'm afraid. So this is far more valuable information to me. How long is the pipeline going to be blocked for? That's what I'm really interested in. Hashtag estimates are useful. Just don't abuse them. So let's talk quickly about trade-off decisions. Most IT departments, most software teams, most digital, whatever you want to call them, are measured as a cost center. And so that leads to strange things like this. Should we choose supplier A for this thing? It's going to cost 100,000 and we'll get it in 10 weeks. Or choose supplier B. It's half price. It's half as expensive. But it does take 20 weeks more. Which one would you choose, A or B? Anyone? Huh? Do you have a date? No? Hey, let me give you a bit more information. It's a must-have feature. Does that help you? No. This is true, they all are. How about this? The return on investment is 300%. Can you make this trade-off decision now? Well, you still can't make it, really. Maybe. It's the same return on investment whether I choose this. Our return on investment would go up, of course, but that doesn't tell me the urgency of it. Benefit cost ratio of 4.6. Still not helping. I mean, yeah, the benefit cost ratio will go up slightly because it's cheaper. Benefit cost ratio of 4.6. Still not helping me. Or, for those of you who are using SAFE's formula, we're going to take some relative number, let's say 5 of business value, and we're going to add time criticality of 1, so we're up to 6, and we're going to add risk reduction of 2, so we're at 8. There you go, cost of delay is 8. Can you now choose supplier A or supplier B? Still not helping, is it? Still not helping at all. How about this one? Anyone familiar with Kanban's classes of service? There's a few hands, yeah. Well, at least with this, I'm getting some sort of sense that it's urgent. Like, it's in the expedite, at least. But I still don't know whether it's worthwhile spending another 50,000 to get it 10 weeks earlier. I still can't make that decision. I still don't know if that's a good choice to make. At least I'm getting some sense of urgency, but I don't know what that urgency is worth. So let me put you out of your misery. So the cost of delay for this thing is $10,000 per week. Now, can you make the decision? It's pretty easy, right? I know what to do. Boom. It's not that difficult. And we see these all over the place. Do we send this to some offshore team or not? It's cheaper, but it's going to take longer. Should we do that or not? Or, I don't get this question that much anymore because everything's gone cloudways, but which infrastructure supplier should we go with? I mean, there isn't a head of infrastructure on the globe who wouldn't go for option A here. They're all managed and measured by the cost that they're dealing with. And so consequently, they're making really dumb decisions. on behalf of the organization. Why? Because they don't have the information they need in order to make a better decision. These are simple ones, but as you know, there are tons of trade-off decisions that we're making day in, day out. If you communicate the value and the urgency to the team, they can make better decisions for themselves. Make sense? Okay. Lastly, changing the focus of the conversation. So anybody heard of Maersk Line? So I spent a couple of years at Maersk over in Copenhagen. It was funny coming into CPH airport, and the smell is exactly the same as it was. It all came back to me immediately. So some lessons that we learned from doing this at Maersk across their whole portfolio, across the whole 100 million per annum. The first is that it's not as hard as people think. It's a little bit like riding a bike. Getting to the first version is a little bit painful. You fall off a few times, a few scrapes and bruises, but once you've got it, there's like 8 different patterns that keep on repeating themselves in an organization. And once you've got those patterns, you kind of know what to do. It's not painful. It's easy. The second interesting thing is that it tends to go viral. When you've got 3 or 4, product owners or product managers within an organization who start using this in their language, and of course then they start getting prioritized in a different way, then all of a sudden everyone figures out, oh, hey, I think I need that number. What is the cost of delay of my thing? So arming them with an economic framework and a way of thinking about the cost of delay helps them to make these decisions. So here's a whole bunch of people making, a whole bunch of product owners, product managers making decisions based on the economics of the impact to the organization as a whole. These are the sorts of things we got. The product owners are especially impatient about applying cost of delay, which is great. This was another one which was a bit of a win. They were figuring out what the cost of delay was before they would go and ask for an estimate, which meant that a lot fewer of them came through for an estimate, which was kind of funny. And even enterprise architecture came down from their ivory tower, and were actually using cost of delay to prioritize their work and their input. And then this was kind of this is when we knew it was working, was when you have very senior executives sending slightly annoyed emails to people saying, don't you realize the cost of delay for this thing is X million dollars per week? And then you know that at that point it's kind of gone through the organization. So what we're doing here is we are changing the conversation. So rather than obsessing about how much something costs, we're much more interested in what the value of that thing is. And then instead of worrying about when it's going to be delivered by, we're much more focused on what's the end-to-end cycle time of these things, how do we shorten that? So all of the cost of those queues become visible to us, and so therefore we need to go and attack those queues. And then rather than worrying about whether the scope is fixed and has been delivered, because we're focusing more on these, uncertainty around the value of them, we're much more interested in the feedback about whether it's actually delivering the value or not. So we're switching away from a focus on scope to a focus on faster feedback. So alongside a whole raft of other things that we did, cost of delay was just one part of the puzzle that we were doing, but much faster delivery times end-to-end within these 2 key systems. GCSS is their centralized booking engine. If you book a container with Maersk, it goes through GCSS. So it's basically the single thing in the middle of the entire organization. SAP is their finance package for invoicing and that sort of thing, which is pretty important for a B2B organization. So any strategic change in the organization required changes to these 2 applications generally. But then across all apps, they're a target for basically halving their cycle time end to end. Much better quality, fewer defects, fewer delays, way fewer patches. A lot more value coming out of the system. Average before $4.10 per dollar invested, up a lot in the 2 key systems that we were dealing with. And not something that we were at all focused on, never made any promises about this, but basically stripping a lot of the waiting time and the waste out of the system. We were basically getting better productivity and throughput for the capacity that they had, which is great. Which, at least perhaps proves this point, is that, you tend to get more of what you focus on. So if you focus on costs, your costs tend to go up. And likewise, without information about value and urgency in your system, the system will optimize for other things. I'm getting told to wrap up, so just quickly. The other really interesting thing is that the distribution of value in your backlogs is highly non-linear. It is 3 orders of magnitude for the top quartile as to the bottom quartile. And if you plot them end to end, rack them up according to cost of delay, you'll see it's basically a power law curve. The first time I saw this, I thought it was a mistake. And then I saw it again and again and again and again, and now I expect it. So basically the distribution of value in your backlogs is highly non-linear. And the other thing to say is that the arrival of these is random. It's not like if you open up for things to come in on a quarterly basis or maybe perhaps an annual planning system. That would be really dumb, because the arrival of these really high cost of delay things is random. So you better have a system that can handle that. Categorization or relative is not enough. It makes sense to go the next step and actually quantify it. The urgency profile enough is not enough, because you need the magnitude in order to do anything with it. It's not just for prioritization. There's thousands of trade-off decisions that are affected by this, and it does change the conversations that you tend to have. So that's me. If you want more, there's a boatload of stuff at blackswanfarming.com, and you're more than welcome to reach out, and I'm happy to field questions if you have any. Other than that, I think we're due to go to the next one.